And so the last time we look at the inverses through the algebraic methods. And remember, an inverse takes the x and y, and in the inverse, it switches it to the y and x. So to find an inverse, all we're going to do is switch x and y and solve for the new variable x, or to get y by itself. So as an example, here's the function f of x is equal to 2x plus 1. Now remember, f of x, we can call this y. So I'm going to really write it as y equals 2x plus 1. And your first step is always have y equals something. Now, from here, I know the inverse says, well, if I want to find the inverse, I need to switch x and y. So I'm going to rewrite this as x equals 2y plus 1. And all it says now is to go ahead and solve the equation. Solve your equations for y. So basically, I want to get y by itself. I'm going to solve this equation for y. In order to do that, I'm going to move the 1 over and then divide by 2. And I get y is equal to x minus 1 divided by 2. And then this is the actual inverse because I found that. And so I can call it f inverse of x. Now, one of the things we do with this inverse is we need to check to make sure it's the inverse. And we learned in compositions that you can compose functions, and that the composition function itself is not commutative, which means that f of g of x is not equal to g of f of x. But a special case of that is the inverse function, where in the inverse, f of f inverse of x, f of f inverse of x is actually equal to f inverse of f of x. Rewrite this. So these two things are actually equal to each other. And what they really equal in the end is they both actually equal x. And if something is truly an inverse, then when you compose the function, the original function, with its inverse, or if you compose the inverse with the original function, you should always get back x. So remember, I have the function f of x is 2x plus 1. Now the new function I compose, f inverse of x, is x minus 1 over 2. I'm going to show you that these are inverses by composing them. I'm going to compose f of f inverse of x first. So remember, this really means take the f function and plug in the f inverse of x for that function. So when I do that, then that's 2 times x. But remember, for the x, I'm going to just leave the parentheses there, plus 1. And in those parentheses, I'm going to plug in f inverse of x, which is x minus 1 over 2. So when I simplify this, the 2's are going to cancel. I'm left with x minus 1 plus x. X minus 1 plus 1. And here, notice the 1's are going to cancel, and it's just left with an x. So that's a nice property of the inverse. If they're actually inverse, you should get an x. And so if I check the other way, if I check the other part of this, which is the f inverse going first now. Let's do that way next. Let's go to that one way first. So f inverse of f of x. And remember, this just means take f inverse on the outside and take the f of x function on the inside. This should also equal x. So this time I have f inverse was, remember, f inverse is this right here, y equals x minus 1. So I'm going to take, for that x at the top, I'm going to do this, minus 1 over 2, right? But for that function, I'm plugging in the f of x function. Plugging in f of x. Remember, f of x is this up here, 2x plus 1. So I'm going to plug in 2x plus 1 here. That's f of x. And look, the plus 1 minus 1 are going to cancel. So I'm left with 2x over 2. And then the 2's cancel. I'm left with just an x. So that also tells me that's the inverse. So let's do one more and verify that we have inverses here. So let's take the equation. F of x is equal to the square root of 2x cubed minus 2. You can think of the inverse as being an undo function. So the inverse wants to undo things. And so to find the inverse, f inverse, remember we start off by rewriting f of x as y equals the square root of 2x cubed minus 2. Then we're going to switch out the y with the x. We'll put x equals the square root of, and we'll switch out the x with the y, 2y cubed minus 2. I'm going to try to solve this equation for y now. So to do that, the first thing I have to do is undo the square root. Well, to undo the square root, we're going to square both sides. The square and the square root are going to cancel each other out because they are technically inverses of each other. So I get x squared is equal to 2y cubed minus 2. I want to get that y by itself, so to attack that, to get that y by itself, I'm going to move this 2 to this side first. And I do that by adding 2. So I get x squared plus 2 is equal to 2y cubed. I still want to get this y by itself, so I need to get rid of that 2 in the front. So now I'm going to do that by dividing by 2. So I'm going to divide both sides by 2. And I get x squared plus 2 divided by 2 is equal to y cubed. And in my final step, if I want to isolate the y's, I need to get rid of that cube. Well, I do that by doing the cube root. Cube root here, cube root here. And that leaves me with y equal to the cube root of x squared plus 2 divided by 2. And remember, we called that final version of this answer f inverse of x is equal to the cube root of x squared plus 2 divided by 2. And so we can actually show that these are inverses of each other. And I wanted you to look at it real quick before we continue. You can see the inverse operations taking place. Notice this has a square root. We've introduced a square here. Notice this has a cube. We've introduced a cube root here. They're inverses, so you're going to see that take place. But let's show it one way. If you can show it, generally if you show it one way, you should be able to show it the other way as well. So we'll show that f of f inverse of x, that should equal x. And remember, this just means f of f inverse of x equals x. So f is the square root of 2. And remember, I have this right here. I'm going to plug in that f inverse function in a second. Make that bigger. Cubed minus 2. So inside of there, I'm going to plug in the cube root of x squared plus 2 over 2. Right? The cube root of x squared plus 2 over 2. And so you can see what's going to happen here. Notice you have a cube and a cube. A cube and a cube root, they're going to cancel. So cube and cube root cancel. So I'm left with this now underneath, which is 2 times x squared plus 2 over 2 minus 2, right? Well, notice you have this 2 sitting in the front and this 2 right here. They're going to cancel. So I'm left with so now I'm down here at x squared plus 2 minus 2. Well, now look, the 2 and this 2 cancel. So I'm left with the square root of x squared. And then finally, the square root of x squared is just x. So we've shown that this original function, the square root of 2x cubed minus 2, its inverse is this function, the cube root of x squared plus 2 over 2.